Everyone, and welcome to Unit 8, Module 41. We're talking about theories and the physiology of emotion. Here are your learning objectives, and here's your vocab. So emotions are the response of the whole organism. It's your physiological response, your expressive behavior, and your conscious experience. So in this module, we're going to talk about 3 different theories of emotion: James Lange, Cannon-Bard, and the Schachter-Singer or two-factor theory. So you definitely need to take careful notes on these 3 theories and make sure you understand them. So first is the James Lange theory. So all of these theories are trying to answer this question: how does our physiological response, our physiological arousal, connect to the feeling of emotion? Which one happens first? Kind of like a chicken or egg situation. So James Lange theory says that we have a stimulus and then our arousal comes first. So we have the physical response of seeing the bear. So our heart starts beating fast, our palms get sweaty, we start shaking, and then we feel the emotion of fear. So it's arousal, then emotion. So my trick to remembering this is, and these aren't the most amazing memory guides, but these just what's worked for me, is that J comes before L. So arousal, A comes before E, emotion. So alphabetically, arousal before emotion, J before L. Okay, so next up is the Cannon-Bard theory. So Cannon-Bard theory says that we feel the physiological arousal, so our heart pounding, sweaty palms, at the same time that we are experiencing the emotion. So they happen at the same time. So C and B are right next to each other in the alphabet. And so your physiological response and your emotion happen at the same time because they're right there next to each other. There are some criticisms of this. For example, there's a study that shows that those with a high spinal cord injury, so they can't really feel anything below the neck, they're paralyzed, they report less intensity to certain emotions. Like they said that anger just doesn't really feel the same to them anymore. It feels kind of empty, but they do get actually more weepy. They get more choked up watching a sad movie, saying goodbye to someone, things like that. So it indicates that some emotions are more cerebral than others, but definitely there's a connection between feeling that physiological response and our emotions. Like it does feed the other. So the third theory is the two-factor theory, also known as the Schachter-Singer theory. Sometimes it can come up named either way. And so this is the more modern theory. And this one says that our emotional experiences require some sort of conscious interpretation. So it's actually adding a new thing. It's not just physiological arousal and emotion. There's a piece that has been missed in those other 2 theories. And that piece is the way we think about what's happening, the way we label it cognitively. So, for example, we see the bear, we have the arousal factor, we get the heart pounding, all that stuff, and then we label this like, oh my gosh, like I'm terrified, and then we experience that. Like the cognitive labeling is important, they say, because, for example, like you can get your heart pounding and stuff like that, and you're not sure why. Like, is it because you're excited? Are you a little bit afraid? Like, what is it? So that cognitive decision is actually really important in determining what kind of emotion. So related to the Schachter and Singer two-factor theory is the spillover effect. So this is when we have a response to a stimuli, and then that response carries over or spills over and affects our response to another event. And our reaction might be totally different. So, for example, a sporting event might cause a lot of excitement, a lot of physiological arousal. Whether they've won or lost, that could cause a lot of arousal. So that spills over into violent behavior. Like, your team just won, why are you lighting a car on fire? It's a spillover effect, or something really scary might have just happened, and so then someone does something and you are overly laughing at it, or you're overly emotional about it, whatever. It's that spillover effect, that one event carries over into another event. The emotion spills over. So they did a study where they had 2 groups injected with epinephrine. One group was told that they were injected with epinephrine, and this is what they should expect. This is what's going to feel like in the body. The other group was told this will have no effect. And then they put them in a waiting room with either an angry person or an excited person, and the group that was told what the injection would do to them, cause all of those physiological responses, the heart beating and all that, they had really little emotion after sitting with that individual. The other group that was not told what they were injected with reported much higher levels of arousal. So if they were in the room with someone who was angry, they cognitively labeled those feelings, those physiological feelings, as anger, and those that were in the room with the excited person appraised those physiological responses to the injection as excitement. So cognition, though, may not precede emotion, according to Zients and Lange. So they're saying that certain emotional reactions don't even go through that part of the brain. They just go right from the thalamus, where sensory information goes, to the amygdala, and then we have emotional response. So there are 2 pathways, according to them, in the brain that you need to know. There's the high road and the low road. The high road is when it goes from the thalamus to the cortex, right? So that's where we can have these conscious thoughts, and then the amygdala, and then we have an emotional response. The low road, though, and this is why they're saying cognition might not precede emotion, the low road goes from the thalamus right to the amygdala. And so depending on the type of emotion, if it's a complex emotion, it's going to take the high road. Love or hate, for example, would be a more complex feeling that they say requires cortex involvement. But low road things like our fears, for example, those just go right to the amygdala. There is no cognitive appraisal involved. So Lazarus and the theory that we just talked about, Schachter and Singer, say, no, there's cognitive appraisal in emotion for sure. So Lazarus says, most stuff that we process is unconscious, sure. But still, even in that low road, there's still a label to that emotion. So even if it's happening at the unconscious level, that cognitive appraisal is still. So the link between emotional arousal and autonomic nervous system, this is the link, right? So here are all the things we've discussed before to when your sympathetic nervous system is kicking in, you're feeling all of those things happen to your body, and that's what some are arguing, like Schachter and Singer, arguing that is involved. There's a cognitive thought about why you're feeling that, and then you're labeling it. So on the topic of emotions, let's talk about being able to use the autonomic system to detect lies. So differences in emotion cannot actually be seen from tracking heart rate and breathing. And the reason why is that, as we've just discussed in some of our previous studies, the physiological arousal that the sympathetic nervous system puts off is very similar if you're super excited about something, if you're nervous, if you're afraid. The same kind of things are going to be going off in your body. So it's not really that accurate. Also, victims, they might go into that fight or flight mode and look like they're lying because of the anxiety in telling their truth. For example, rape victims are much more likely to fail a polygraph because their body is they're trying to speak their truth, and that is going to put you in a fight or flight mode, especially when you're hooked up to a polygraph machine. So the guilty knowledge test is actually much more scientifically based, and it hooks you up the same kind of way in terms of physiological response, but it's focused on questions that are crime scene. They ask a ton of questions, but some of the questions only the police and the person who did it would know. And so that's what they're looking for, those specific questions. And that actually is more effective according to research, but it's very entailed and it doesn't really get used that often. Forensic neuroscientists argue that you can use the fMRI and we know what parts of the brain are involved with deceit. And so they can use fMRI machines, and that's way more accurate than using any sort of like heart rate monitor. But in 2010, the federal court said, we're not ready for that yet. There's a lot of people who bounced back and critiqued that, saying, well, right now what we're using isn't that great either. An fMRI machine would definitely be more accurate. So takeaways. James Lange, J before L, physical before emotional. Cannon-Bard, C and B, happen at the same time. Two-factor theory, the factors are physical response and cognitive appraisal. And then high road versus low road. Remember, high is the cerebral cortex, the highest part of the brain. Low road, it goes right from the thalamus to the amygdala. Lie detectors, not reliable, and generally not admissible in court. That sums up Module 41, and I will see you in class. Thanks, guys.